Good evening, everyone, from the Death Valley region of Eastern California. Welcome to another night of COVID-friendly, pandemic-safe astronomy from the desert. We got a nice, calm night this evening for our stargazing. There have been some high, thin clouds around all day that floating by. It's been mostly nice, and right now it's looking pretty clear, but the sky is a little soft, and I know there's some high, thin stuff going around up there right now, so we may experience some of our sub-exposures getting a little fuzzy and being rejected if a little passing fuzzy cloud goes overhead or something, but for the most part it's looking like we are in real good shape for tonight. The weather has cooperated. The last couple of nights have been we've been on and off clouds, on and off wind, kind of the standard desert thing going on, desert winter thing. The last two nights the weathermen have been predicting clouds that ended up not showing up either night, so I decided to not do streams the last couple of nights because of that, and then the clouds didn't show up. But hey, that is sometimes how it happens. In any event, let me start off by turning that off and start off by going over what my setup is. The telescope and mount that I am using. So that is my little 6-inch imaging Newtonian, the white telescope up top there. And it's a reflector telescope. It's a Newtonian reflector telescope. And it's 6 inches long, and it has a focal ratio of 4, which is fairly fast. It's considered a fast scope, which is great for using a camera with, because the faster focal ratio allows the camera to collect photons a lot faster than a much slower or longer focal ratio scope. And so it's wonderful for imaging, and so that's what I do with it. The very top there you can see sort of a tower of stuff coming up above there. That's the focuser, and that's where the either eyepieces can go, or in my case where the camera sticks in, because I have astronomy cameras that just replace my my eyepiece, so that we can see what the scope is seeing. And the mount that it's riding on is the black and thing with the orange ring on it is Celestron Evolution Altitude Azimuth mount, and it's a great little mount, and I love the simplicity of setting it up, and it just kind of controls the scope for me. And then it is sitting on you can see my homemade wooden, what's called a wedge, and that basically allows your mount to tilt over and point exactly at the northern celestial pole around which the entire sky rotates. Actually, that's the Earth's rotation, but to us it looks like the sky is rotating. And by pointing your mount directly at the northern celestial pole as precisely as you can, it allows the telescope to track the objects that you're looking at much more accurately. There are other kinds of telescopes called German equatorial mount scopes that are designed to kind of incorporate this all into one mechanism. But I just use my homemade wooden wedge there to achieve that equatorial alignment. And it and the cinder block pile there, that's actually glued together with construction adhesive so it stays in place and sturdy. All those two things, the wedge and the concrete block, stay outside all the time, permanently polar aligned. And that means my setup becomes very simple. The telescope and the evolution mount are what goes inside, and that's all that has to go inside. So my setup is fairly quick and easy to have my equatorial mount. So that is the telescope that I am using and the mount that I'm using. And tonight we're using the Monochrome camera to see our galaxies. So that is a ZWO ASI 178 monochrome camera, for those who know what that means. And So the software that I'm using is going to be, I'm using Open Broadcast Studio for my broadcasting software, and so that's what's allowing me to then send the stream to YouTube so that you guys can see what's going on. So I think we're going to start. This is a good one to start with here. Now we're on Aldebaran, which is in Orion, and that was the star that I used to actually focus my scope on and get everything set up. And so now I'm going to swing the scope around over to this galaxy here, swing around to the western sky. This is the Superman galaxy, which is a really fun galaxy that I have imaged before, but not with this new setup. So I'm kind of looking forward to this. Let's see if we're seeing something close here. I think it might be up here. Let's see what we got. Alright, my gain is maxed, so that's good. Let's try stretching the histogram a little bit. Yeah, it's right down here. There's a fuzzy smudge right down there. So let's try and bring that up in my view so that we center it in the view a little bit better. Yeah, let me just do one more. Just do a couple of seconds here just to make sure, but yeah, that's definitely it. Okay, so that's definitely the guy up there. So I've got all the other things set right. So let's just go to my sequence here for starting the imaging with the 178. And that will set my profile and set all my settings to where I want it to be, including a nice 60-second exposure, and it will start the stacking for me. So and we'll see what shows up here. I'll probably actually need to reset this, which still is showing color sliders, so it still thinks it still has to get the memo here that I have my monochrome camera in, but that should happen pretty quickly here. And let's see, while we're waiting for that first sub to come in, Superman is NGC 7479. Let's see what Wikipedia has to say about that. NGC 7479. Doink. Also known as Caldwell 44, is a barred spiral galaxy about 105 million light years away. Wow, and that definitely is blurry. So we are going to clear that stat. We're going to clear that one out. That one was definitely some movement there. I guess the scope hadn't quite settled. So we'll just reset that and let it start again. It's a barred spiral galaxy about 105 million light years away in the constellation Pegasus. It was discovered by William Herschel in 1784. The supernova SN 1990U and SN 2009JF occurred in 7479. And GC 7479 is also recognized as a Seyfert galaxy and a liner undergoing starburst activity. There we go. That looks like a lot more like round stars. And once we adjust the histogram to sharpen things up a bit here, we'll be able to see more with that. Okay, and I forgot to put my enhancements in. We want to put these in because that sharpens up the details nicely. Alright. And now we'll let that collect some photons. Stretch it a little more. Gotta brighten it up so you guys can see it. But you're probably starting to see why it's called the Superman galaxy. Anyway, back to our, right up here, it's a Seyfert galaxy and a liner, L-I-N-E-R, I don't know what that means, undergoing starburst activity not only in the nucleus and the outer arms, but also across the bar of the galaxy, where most of the stars were formed in the last 100 million years. Polarization studies of this galaxy indicate that it recently underwent a minor merger, and that it is unique in the radio continuum, with arms opening in a direction opposite the optical arms. So it's recently had a merger, meaning, I'm assuming, that another galaxy in recent galactic history has collided with it. So that's kind of interesting. And that it is unique in the radio continuum with arms opening in a direction opposite to the optical arms. This feature, along with the asymmetrical arms of the galaxy and the intense star formation activity, are attributed to a merger with a smaller galaxy. This galaxy is similar both in size and morphology to the barred spiral NGC 1300. So recently had a merger, a corporate merger with another galaxy. And we need to darken this up a little bit. There we go. And probably even brighten this up a little bit. Give that a little more contrast. But it's a very neat little galaxy, and it's a neat one to look at. It's got a nice shape. Let me some nice arms, and you can see obviously the bright up and down part is the barred spiral, because the arms stay bright and straight for a good distance across the galaxy before they start to then spiral and swirl around. So this is called a barred spiral. Probably should have muted my mic for that, but it really did taste good, that water. Got some sort of little artifact down here. Not really sure what that is. I think it's a hot pixel smudge or something from the camera. I don't think that's a celestial object. Make sure I've got the right dark going in here. 178 mono, 60-second. Yep, that's the one. Make sure we have the right dark frame, because what a dark frame does, why it's important for imaging, is every camera has noise. You know, when you zoom in, you can kind of see the pixelation and the noisiness that's in it. And when I'm taking my first couple of sub-exposures and they get stacked, it's all pretty noisy, and then as more and more come in, more and more of the noise gets averaged out. By noise, I mean the background speckling and all that kind of stuff. It gets kind of averaged out. And but every camera has built-in noise. The things around the edges of the camera, some of the pixels go a little wonky and are what are called hot pixels, where they will just get really bright or turn colors or something. Every camera has those kinds of artifacts. They're just imperfections in the way the camera works, the way it was made, all that kind of stuff. And so if you start stacking your images, those hot pixels will add up and turn into significantly bigger aberrations. And so what a dark frame is you put the camera in your telescope and you cover your telescope, and you just take a number of exposures with the camera covered. And what gets taken is, what the result of those exposures is, the only thing that shows up as a light source are the hot pixels and the camera defects and the amp glow and those kinds of things that are the defects you don't want to see in your images. And so by covering your camera and taking these special dark frames where the only thing that shows up in the image is the imperfections, the image capture software, in this case I'm using SharpCap Pro, can take those dark frames and process it against the incoming images and automatically deduct everything in the dark frame from what's coming in the images. And the result of doing that process of subtracting the dark frame is that you have an image which should be fairly pure, that should look like what you're looking at without all the aberrations and noise from the camera. And those dark frames are dependent on a number of things: your exposure time, your gain level settings, a number of the settings in the camera basically. And so you have to take different dark frames depending on what you're going to do for the night, what your exposure lengths are going to be and what your gain levels are going to be. And anytime you change those, you have to take new dark frames. So generally speaking, we have a pretty good idea of what we're going to shoot our images at. In this case, I'm using 60-second exposures and a gain of 200. And I know about what the temperature of the camera is going to be. And so you take your dark frames at about with all those conditions set, and then when you go to do your actual imaging, you use those same settings and match the dark frames up with them. So dark frames are a very cool thing, especially if you're using a noisy camera like this 178 is. It's got plenty of little noise in it, but it's a wonderfully high resolution camera. It gets a lot of detail because its pixels are very, very small. And the pixels on the sensor are very small, so you can see a lot of detail in here. I mean, you can actually see there's a kind of a little dark lane through here, and a brighter lane here with some little puffs of light just in here that are obviously they're little bright spots that are in here. So you get to see a lot more detail with a fine pixel camera than you do with a camera that has bigger pixels. The price you pay for that is that the fine pixel camera is not as sensitive. In general, the larger the pixels on the camera, the more sensitive to light it is. So sensitivity and resolution, detail, are kind of the trade-offs you have to make when you're looking at a camera. And for this one, I trade off sensitivity and take the detail. and it gives pretty nice detail. You can see there's a nice little puff of a cloud out here from another piece of it out here, even outside the main swirly spiral. It's a pretty neat galaxy. Let's give this one more adjustment. A little more contrast. Again, at the risk of making it a little bit noisy, but with the noise comes more of the galaxy. So sometimes you have to make that compromise. And I got another ignored frame here. But it doesn't say why. Just ignored it. Failed to calculate alignment frame notes because could not align. Well, it was just a blurry, I guess just a blurry sub came in. And that happens. But I think it's coming out pretty well though. And these are such faint distant objects, I usually like to spend a couple extra minutes on these. As opposed to when I'm using the color camera, and I'm typically on a much brighter, shinier object. And again, that my color camera has larger pixels, so it's more sensitive, and so it picks up the objects a little bit quicker. But it doesn't have the detail this one does. And you can even see there's 2 or 3 little puffs of light in here where there are bright spots. Bright nebulas or large star clusters or something in this galaxy. Possibly even novas in this galaxy that are just kind of places where it stands a little one there, one there, one there, one there. Just little knots of brightness in the swirling arms, where some sort of activity is going on there, star formation or whatever else. That's the Superman galaxy. Let's see, where are we going to go next? We're going to just keep heading up, I think. There's a few around Pegasus. You just stay up above Pegasus Dwarf galaxy. Yeah, that's a little dim. I think we'll not do that. Come on. Another real dim one. Caldwell 43. Oh, the little sombrero. That's a nice one. We'll do that one next. We'll get this guy finish this one last sub, and then we'll head over and do that one. The little sombrero. But this is the Superman. Cool. All right. Let's pull up the script to go to the next target. And we will go to it. Climb up a little higher in the sky. Yeah, this is a nice edge-on galaxy. Well, I'm getting a weird message here. Hopefully you guys didn't lose much there. I'm getting a message from my broadcasting software saying that it lost connection. But, well, hopefully you guys are still with me. Looks like you are. Okay, so, not you, you. I've got that. I'm thinking it's going to be thinking it's up in here, based on what I'm seeing in Stellarium. Oh, no, it's down here. It looks like it's way down there. Okay. Let me zoom out. This is one thing I really would like to add to the scripting, is to be able to reset the zoom to full focused out. Okay, let's move that sucker back up in there then. Move it up just a little bit in the frame. That's probably about perfect, actually. Okay. And then we will start the imaging. Clear out the old one. And start our stack on this one. And this one is NGC 7814. NGC 7814. Okay. Is a spiral galaxy about 40 million light years away. So this one's a lot closer. The galaxy is seen edge-on from Earth. It is sometimes referred to as the Little Sombrero, a miniature version of Messier 104, which is the Sombrero. The star field behind NGC 7814 is known for its density of faint, remote galaxies, as can be seen in the image here, in the same vein as the Hubble Deep Field. Okay, well, good. Let's see how many other galaxies we can see tonight then, while we're looking at it. There it is there. Coming in pretty nice. This is only 40 million light years away, so this one is a lot closer than the Superman galaxy, and yet, interesting enough, this one looks smaller. So, tells you how relative in size, the Superman galaxy is probably just a lot larger. But once we've collected a few more sub-exposures here and stack them on, it'll probably fill out and widen a bit, because we are looking at it almost perfectly edge on, and so you can kind of see there's a dark lane right through there. So as we get more stacks on here, it will probably get wider and brighter. So, well, hello Guzzy Alpha and Kona Skies. Welcome to the Star Show here. And according to Wikipedia, there also are going to be a number of other galaxies in the field here. So we will, as we begin to collect more and more sub-exposures and collect more light, things get a bit brighter and clearer, we'll be able to look around and see how many other galaxies there are. I think I can already see one over here. But we need to collect a few more subs to get the noisy background quieted down a bit. But every sub-exposure that comes in, it'll get better. Yep, this one's the mini version of the Sombrero galaxy. So, and it's in a pretty rich star field of galaxies too. So, hopefully we'll be able to see a few others in here. You're very welcome, Kona. I love doing astronomy. I have ever since I was a kid. My parents bought me my first little telescope. I was a teenager, if I remember right. And it was a Sears, something out of the Sears catalog, I'm sure. and like most of the like most scopes from those days when they didn't spend a bunch of money on it, so it had its challenges, but I was able to see so much with it. And oh, hi John. Okay, John is Guzzy Alpha. Okay. Well, thanks for coming, guys. I was just hooked. I mean, I was out for hours with that scope, and I grew up in rural New Hampshire. And of course, this was 40 years ago when light pollution was much less than it is now, especially up there. And I was just able to see so much stuff. It was just awesome what I could see with it, and I was just hooked. I mean, mostly it was, of course, planets and the moon and things. Do I still have the Sears telescope? No, no, Kona, I don't. I don't even know. I doubt my parents still have it. I don't know what happened to that, but no, that sucker is long gone. And it was, of course, it was not an expensive telescope, so it was on a rickety tripod, which could hold the weight of it pretty well. But if you tried to use any sort of high magnification, it would just jiggle all over the place, and the slightest little breeze would jiggle it all over. But I was hooked, and so off and on throughout my life, I have done astronomy, and usually the reason that I go back off it again is because I'm always underwhelmed by what I was seeing. I mean, I did not expect I was going to see, the kind of images that professional astronomers with huge telescopes on mountaintops were seeing, but still, I wanted to see something a little bit more than faint gray fuzzy things, and so I'd do it for a while, and then I'd quit, sell my stuff, and go do something else, and pick up another couple hobbies, and then I'd come back again, and I want to do astronomy again, and I'd come back to my love of astronomy for a while, and back and forth, and it wasn't until 3 years ago when a friend gave me a little motorized telescope, a Meade ETX70, and I started using that, and that was pretty cool. That was my first go-to scope, my first experience with having to star align and having a keypad that I could actually send it to things. That was pretty cool, and most importantly, it also tracked with the sky. And he also had purchased a Meade electronic eyepiece with it, and which of course is an extremely low quality webcam based camera, but it was good enough to see bright things like the moon and the planets and the stuff in the solar system, and even some of the brighter deep space objects. And so I then started, wow, I can use a camera in a little telescope like this, and sure enough, I could. And I wasn't able to get very good images out of it, but it caused me to upgrade. So I upgraded to a Revolution imager, and then I upgraded to a ZW0224, and then I upgraded my scope, and of course, the whole progression. But the point is, in going to a camera, even those first cameras, which weren't very good and weren't very good quality images, but what I could see in them was amazing. This is what I had been waiting all of my life for. This is the kind of stuff that I wanted to see 40 years ago out of that Sears telescope, and of course wasn't able to, because that's not what those can do. But with the cameras, it just opened a whole new world, and it's doing that for a lot of people these days, simply because the camera, because of its high levels of sensitivity, much more sensitivity than the eye, can also help you cut through light pollution. And so for those of us who live in light polluted urban and suburban areas, which is most of us, you get even a cheapo light pollution filter and a camera and stick it into your go-to scope that tracks the sky, and you will be amazed at how many things you can see again that you could never see from your backyard otherwise. So it's becoming a very quickly growing field of astronomy. It's called EAA, or electronically assisted astronomy, and it just really opened up my love of astronomy again. It was just really, really cool. Let's see, I haven't checked the histogram here in a bit. It's looking okay. Let's see if I can brighten this up for you guys a bit. It might be a little too much. Brighten it up at the risk of pushing it too much, but I've gotta brighten it up so you guys can see it a bit better. You can see it's widening out now. We can see it goes all the way out to here at this point. And you got a nice dark dust lane right through here with a bright core that almost blows it out completely. Goes right through there, but you got a nice dust lane across there. And definitely also seeing, yeah, you can see there's clearly a galaxy there. Nice little spiral probably there. There's definitely a fuzzy blob in here. Where else? Where else can we see galaxies in here? I think this might even be one down here. That's definitely one. That's a nice bright one there. Hunting those galaxies. A couple of these are pretty soft and fuzzy out here, but they're probably just faint stars. There is something here. It's also very faint and fuzzy, but can't really tell what it is. Could be just an artifact on the camera. But yeah, I'm thinking this here also. This is a fuzzy spot with a bright core. That's probably another galaxy there. So I have to turn up. I have to stretch the image so much to brighten it up for you guys to be able to see clearly that I'm left with something on my screen that has a lot of artifacts and it's hard to find things on it. So I'm actually having to look at what you guys are seeing on my second laptop, where I'm following the stream, and to see what you guys are to see what's actually on my screen. And I don't have this scrolled up all the way. There we go. So there's definitely a few in there. Little sombrero. Okay, well, let's see. What are we going to see next? Continuing to work our way up the sky, so we're not setting on ourselves. 35, 40, yeah, we're doing good. Ooh, that one's Mag 15. That one would be very dim. Here's an active over here. What's this one? Another very dim one. Not sure we'll be able to see that one very well. You see 7337. And I want to keep going up. That one's down. Well, some of these are all right on the edge. Okay, there's the whirligig. I think we might try this one. This one is supposedly Mag 9, although a surface brightness of 15, but we'll see. I better synchronize on that. Go back to this. I think we'll try and do that one next. It might be a little faint for us, but we'll give it a shot. Yeah, John, you're right. Yeah, the boxes always said these fantastic numbers of powers. 500, 600 power. You'll be able to see the aliens walking across the moon. And while they did technically have the eyepieces that would get you to that power, because of the ricketiness of the tripods and the ricketiness of the focusers and all that kind of stuff, and the breeze that was causing the scope to shake and jiggle, you could never really use more than about half of the power that they sent with the box. But that's okay. That's why we kept upgrading, kept going for bigger. All right, so there's a little sombrero. Let's move on to the next one here, which may be more of a challenge to see. So this may be, yeah, it's looking like a kind of a globule of stars, so it may be a pretty loose concentration, but let's see what. Yeah, so we have 1, 2, 3 stars here in kind of an arc, which I'm pretty sure are these 3 right here. And so this is going to be just above, so I think it's going to be right up in here, if I'm correct. Even, let's try doing a 4-second exposure with the histogram stretched. I'm thinking it's going to be up here, but boy, it's very faint. It is very faint if it's up there. Now let's try moving it down into here a little bit. Just move it down a little bit into the... Oh, shoot. That moved. Oh, of course, because I'm in 4 seconds there. I'm on 4 seconds now. Okay, that's probably about good enough. Yeah, and there's the bright star that's above that these 3 are kind of pointing to. And there's the bright star we just brought in. So I think it's over here. So let's go ahead and see if we can pull this in. This is going to be a pretty faint one. So this might be a little bit of a challenge for my little 6-inch newt here. But we'll see. I have my Stellarium set to basically eliminate anything over Mag 15, because that's pretty dicey for me to try. Usually I can't bring that in. So this is just on the border, just on the edge. The Running Man Nebula, John says. Yeah, we could, if that's a request for something to look at tonight, we certainly could look at that. It's way too big for this 1/2-inch sensor. I just looked at the Running Man on a week ago. I did a live stream, and or was that? Well, that might have been on Friday. Anyway, within my last 2 streams, I have looked at. Oh, I'm thinking of Pleiades. Running Man. No, Running Man would be fine. But I have looked at that. I think that was last Monday, because that was part of the Cloudy Nights January Observers Challenge. So, but if you would like to see it again through the monochrome, we can see what we can see in the monochrome. Oh, why am I staying on this? I'm stuck on that. Oh yeah, there's definitely a fuzzy bit in there. Well, we'll have to see what comes up. But there is definitely a fuzzy cloud there. What is this? IC 1613. Oh, Caldwell 51. Let's see what Wikipedia has to say about this one. Come on, computer. Caldwell 51. There we are. Let's see if it says anything much. IC 1613, also known as Caldwell 51, is an irregular dwarf galaxy visible in the constellation Cetus, near the star 26 Cetus, which is the bright star there, right up there at the top. It was discovered in 1906 by Max Wolf and is approaching Earth at 234 kilometers per second. So this one is actually blue shifted. It's actually coming right at us. It's a member of the local group. It has played an important role in the calibration of the Cepheid variable period luminosity relation for estimating distances. So they used it to figure out how to make distances more accurate. Other than the Magellanic Clouds, it is the only local group dwarf irregular galaxy where RR Lyrae type variables have been observed. This factor, along with an unusually low abundance of interstellar dust, both within it and along the line of sight, enable especially accurate distance estimates. In 1999, Cole et al. Used the Hubble Space Telescope to find that the dominant population of this galaxy has an age of approximately 7 GYR, and I don't know what that means. Using its Hess diagram, they found that its evolutionary history may be similar to that of the Pegasus dwarf irregular galaxy, both of which are classified as DDO systems. That's about all that's interesting in there. But did it actually say what its distance was? No, let's see. Okay, so it's 2.4 million light years. So this is one of our very local galaxies. This is actually about as far away as Andromeda, which is one of the closest. I think it's actually the closest galaxy to us is Andromeda. And so this one is just about that same distance away. It's a little under 2.5 million light years away. This one is just much smaller and dimmer. Andromeda, of course, being so bright that it's the only galaxy we can see in the sky naked eye if you're under fairly dark skies. So this is obviously much dimmer and smaller, but it's a pretty close one. And again, even in here we see another, there's a galaxy right there. That is a soft fuzzy smudge. But you can see now that there's some of the clumps of it have come through, the bright, cloudy clumps of it. It's an irregular galaxy, so when you look at it doesn't have a defined shape to it. So it's a little hard to pick it out from the foreground stars that are going to be in our own galaxy. Any of the stars that we see in this image are obviously in our own galaxy, because other galaxies are so far away that we can't hope to see individual stars from them. So it's kind of hard to pick out what are individual stars from our galaxy that are in the foreground and what is the actual galaxy in the background. And this is such a faint little guy that I don't know that I'm going to be able to bring it in any much more. But it is pretty neat. An irregular dwarf galaxy. The two biggest and closest galaxies, Andromeda and Triangulum, or M33, are so big they're bigger than my sensor. Andromeda is way bigger than my sensor. I can only get other arms at a time in my view with that. Even my 533, the color camera I have, which has double the sensor size that this does, even in that I can't fit Andromeda in that. That one I can fit Triangulum. On this camera I could only get probably about half of Triangulum in it. But we'll probably give a shot to that tonight too, because why not? It is one of the most spectacular galaxies we can see from Earth, so it's a good one to view. But it's a bit bigger than my little 178 sensor, so we'll have to see. We'll have to see. It's been a while since I shot it as well. You start to see more of the cloudiness starting to come out, starting to get a little more clear as we collect more and more exposures on this. Get a little more contrast in things. This part back here is starting to darken a bit. And more of the cloudiness, the bright cloudiness of the galaxy itself is kind of coming forward. Alright, time for another drink. And as I said at the beginning of the show tonight, it's we've had high, thin, wispy clouds all day. So we got a bit of a Pacific flow in the last couple of days, which has made for some nice days, but we've got high, thin, wispy clouds floating around. A little bit more humidity in the air, so our the sky's a little mushy, so it's I'm seeing a little bit brighter background right now than normally, just because it's just because of the weather. So might not get the darkest sky backgrounds tonight from the images, but it's clear enough that we'll be able to see some fair. And this is probably going to be one of the most challenging ones we'll do. I just wanted to see if I could bring this in, and it looks like it's coming in pretty nicely. We could probably spend half an hour just collecting data on this to have it to come in, for, much more sharply, but obviously we're not going to do that. John asks, so the ASI cameras are 178 and 594. No, the ones I have are the 178 mono. That's the one we're using tonight, and the 533 color. And they're both by ZWO, and they're both good cameras for what they do. The 533 is just a phenomenal camera. It's one of the latest crop and latest technology cameras, where you can see with this camera right now in this image, I've got pretty dark here and then pretty bright up here. That's probably to some extent amp glow, which is just the sensor itself warming up in one place versus another. I think some of it may just be a little bit of humidity and moisture in the air too. But sensors experience amp glow. Is just part of how they operate. It's one of their artifacts of the way they work. And the 533 in the latest crop of CMOS astronomy cameras has no amp glow. So it's a very clean sensor. It does have hot pixel noise. It does suffer from that a bit, so you always want to use your dark files with it. But it is just super sensitive and a super clean sensor, and it's just wonderful to use. The 178 also is a great little camera. It's a much older technology camera, but it's got really small pixels, which provide much finer detail at the expense of sensitivity, so it takes longer to collect that light. So I'm really happy to be using my wedge and be able to use 60-second exposures with this, because it will help a lot with overcoming that lack of sensitivity to gain the resolution that I like and the detail that I like in this. And you can see in the galaxy some of these pockets of brightness that are clearly not stars are starting to come through in this galaxy, which is pretty cool. Yeah, you have the 183. Yes, that is the big brother to the 178. And I'm actually looking to upgrade probably to a 183. Well, actually, what I'm looking to upgrade to is a cooled camera. The desert is great for dark skies, but in the summertime, it's a little hot for doing camera work where your exposures are going 30 seconds and 60 seconds, because the sensor starts getting warmer and warmer, which means it just starts getting noisier and noisier and lots more pixels. So I'm looking to get into a cooled version of one of the two. And the problem with the 178 right now is that they don't make the 178 cool anymore. They used to, but they stopped making it a while ago. Like I said, it's an older technology camera. So I have the uncooled version, which when sitting out in these kind of temperatures is just fine. In fact, let's see what temperature it's running at now. So I've been running 60-second exposures for a while, and it's only at 11 degrees centigrade. So you know, it's in the wintertime it stays cool. It's not a problem. But in the summertime, I really am going to need something cooled. So either I will be getting a 183 cool, or I keep combing the used market, and 2 or 3 times a year somebody will come across with a 178 cool that they bought a couple, 2, 3 few years ago, whatever, and they just don't use anymore. And so every once in a while, a 178 Pro, or the cooled version, will come up for sale, and so I'm hoping to snag one when it comes up. And if a good deal on a 183 comes across, then I might step up to the 1-inch sensor. But it's a lot more money and a lot more camera than I really need for my hunting my little galaxies, so I'm not really married to the 183. The one thing that they do have going for them is that they are much more prevalent and they come up for sale much more frequently, so I don't know. We'll see. Okay, so that is our dwarf galaxy. So that was pretty cool. Let's see. Where's this? Yeah, that's okay. There's that. Yeah. All right. Let's see, what do we got here. Well, let's just keep going up here. Oh, the whirligig. Okay. Yeah, I said I was going to do the whirligig. So I think we'll do the whirligig next. Next, target, run my script, which stops the stacking, sets my exposure to 1, gain to 500, so I can find things easier. Really like the sequencer in SharpCap Pro. I'm running the beta 3.3 beta of SharpCap Pro and playing around with the sequencer, and I'm really liking it. It's working real well, and just really helps you through those repetitive tasks where you're just doing the same things over and over and over again. Okay, so there's 1, 2, 3 stars, with the brighter star being in the middle, which looks a lot like these 3 right here. So I think, yeah, and so it's going to be right in here. So let me just actually just bring it down a tiny bit here. And maybe a little bit more into the middle. Let it just kind of drift a little bit more into the middle of the sensor where things will be a little bit cleaner. That's probably good. Boink. Alright. Give it a couple of seconds to make sure it's settled before we start running 60-second exposures on it. Okay. Yeah, you got yours for lunar and solar imaging. Yeah, that's what a lot of people use the tiny pixel cameras for, the 183s and the 178s, is for solar system work. Lunar, solar, sun, and planetary. Because the brightness of all of the solar system objects, of course, overcome the lack of sensitivity in the camera. And because they're such close objects and there's so much detail in them that you really want to have the fine pixels for the detail. So you get all the benefit without having to worry about the downside of its lack of sensitivity, because you're doing really bright stuff that have a lot of detail. And so yeah, it's they really are preferred for doing that kind of work. What can you see? Is it like SGP or just SharpCap Pro sequences? I have never used SGP, so I can't answer that. If what you're asking is whether the SharpCap Pro sequencer can control things outside of SharpCap, the answer is no, it cannot. It can only control things within SharpCap itself, at least, and anything that, of course, SharpCap can control through the control. SharpCap can already control your camera. It can control your mount. It can control, I believe, a focuser, although I've never used one, so I don't know. I have no experience with that. So it can, the sequencer can or will be able to control anything that is inside of SharpCap or anything that SharpCap can control, but it's not going to be able to like start external pieces of software or anything like that. I think it can start might be able to start shell scripts. Can it do that? So here is the actual sequence editor itself, and so it's very simple. Grab a block, drop it over here, and then make its settings. So it's a very simple build process, a very high level, or is that low level? I think it's a very high level, way to script. You're not actually writing any code, and so you can control. And each tab has the different things that can be controlled from it. And for instance, I could take this, instead of waiting for 2 seconds, I could double it out to 4, and then go here and save it. Boom. And so now that when I run that script, that's what it'll do. There is, let's see what MISC has. Connect, disconnect objects, run with parameters. Oh, see, it can run programs. So it can run. So maybe it can start external programs. Show a countdown, show a notification, show a prompt, wait for, wait until. I know at the current time it can't do conditional statements, so there's no if-then stuff yet, no sort of looping stuff going on yet with it. but that that may just be stuff that will come in the future. But right now you can't do any of that stuff. So, but yeah, there's and this is still in beta. There's very little stuff in here. So there's already a lot here, but not compared to what's coming. There's going to be more and more functionality being added to this thing all the time, and so it's going to be really cool. I mean, even just in my first night of using it, I came up with a short list of things to correct and things to add, functionality to add, and I just got on the beta forum for the software, and Robin Glover, who is the developer of SharpCap, is very responsive, and in fact this year he has gone full time on it for the first time. Just a few, beginning of this year he's gone full time on it, so it's definitely going to be getting a lot of love and a lot more power going on there. So oh yes, and that the polar alignment tool, there's a lot of other tools in here as well that are part of it. There's the polar alignment tool here. The plate solving is really cool. You can do a sensor analysis and then do a smart histogram where it will actually tell you, based on your sky conditions currently and the analysis it's done on your sensor, your camera, it can tell you the optimal exposure levels and optimal gain settings for any particular object that you want to shoot. It will also let you why did that suddenly get really dark? Whoa! I must have accidentally hit the live stack button. Yeah, I must have accidentally touched I turned off my live stack accidentally when I was futzing around with the menus. He has tools in here for various different tools for setting up your focus. I just use a Batinov mask, and I have a good luck with that. But he has several. There are a number of tools in here, including a Batinov mask tool that you can use, and other things in here. Feature tracking, I'm not sure. I think that's like for doing, well, you talked about lunar work. I think this actually gives the if I understand it, and I haven't really looked into this, so I could be totally wrong, but I think feature tracking is tracking an actual feature on something you're observing. So if you're shooting the moon, as it were, it will actually track features and help guide your camera, I think is what that is. It'll actually help the tracking of that kind of stuff. I may have that wrong, but anyway, it is a very, very powerful tool. It does have a bit of a learning curve, but it's just for people who are doing EAA and even astrophotography. It's a great tool. It's a great tool. Although SGP is kind of the gold standard for most of that kind of stuff. Is that what PhD stands for? I've never used guiding software, and I don't think I ever will, but I wasn't sure what PhD saw. I thought it was just something to make you feel smarter. But what do we got here? We've rejected some frames suddenly. And what have we going on? Frame not stacked because could not align. Yeah, well that one was on me. Frame not stacked because live stacking is paused. Oh, darn it. Okay, so we just lost 3 minutes of data there because I guess not only did I have to re-click the live stack button, I also had to come down here and click the resume button. Dough. Like I said, SharpCap, very powerful, but pretty complex, and a lot of buttons to push and a lot of things to keep track of. So there is a bit of a steep learning curve on it, but once you figure out the things that you want to do with it, you get fast on it pretty quick. So they it's not too bad once you get used to it. What I actually found when using it, and I think this is a practice that applies to all complex pieces of software, is read the manual, then use it for a while, then read the manual again, then use it for a while, then read the manual again, and every time you come back and reiterate, iterate on the manual again, you pick up so much more than you did the first time because now you have a lot more context for it. So that's what I did with SharpCap. I used it for a while, and then came back to the manual and got a lot more out of it, and then went and used it again for another couple, 3 months, whatever, few months, and then came back to the manual and got a lot more out of the manual again. So yeah, so it's it's really, in terms of PC, I think it is for EAA use, it's the best thing out there. So I really have enjoyed using it. That sub also got rejected. Why did that one get stacked? Oh, that was just FWHM is too high. And the FWHM is basically a filter that looks at the individual frame and says how clear is it, how clean is it. And if a little cloud moves overhead and fuzzes it out or mushes it out, it'll look at that and say, nope, it's not very sharp, and we'll give it a low FWHM number, which stands for full width half measure. And it's just a way of checking the sharpness and clarity of an image as it comes in. And so this one was determined to be not very sharp, although this one actually doesn't look too bad from my perspective. But anyway, yeah. So now there's the new one that came in, and I'm not seeing much difference. But anyway, the software sees stuff I can't see, so there you are. Half width full maximum. Half width full maximum. Half width full measure. Okay, maximum is it's maximum, not measure. I guess it doesn't matter because neither one makes sense to me. I'm not really sure. I'd have to go back and look at it. I think I looked at once what that actually means technically, but all right. Well, after having 5 subs ignored, we're now back to stacking correctly again. So this one's just kind of a fuzzy, puffy sort of thing. But if I stretch it real hard, might be able to see some a little bit. It's half width full measure. Yes, a measure of what? I don't know, but that's what it's called. So this is kind of a disk. You can actually see that there's a little bit of structure here. Again, tonight things are a little bit mushy in the sky, so I'm not getting a lot of clarity. I'm not getting a lot of clarity in the image, but you can see there is a little bit of just a little bit of structure, and there's a kind of a sharp line here and a little bit of a line there and there. So this is a disk. I would need to collect some more data on it to really be able to see it clearly, but you can kind of see it coming in there. And also you can see another galaxy here. There's one over there. These actually look like galaxies. See how fuzzy they are compared to the stars that are right next to them? That's a good sign that they're probably good. This is also probably a galaxy. It's a fuzzy core with a fuzzy outer rim. This is probably a galaxy. Actually, you can almost see some spiral coming off that, and maybe a disk. And that's a star there and a star there. Stars are much, much sharper. And then there's a bunch of fuzzy things. These are too small to really tell for sure. But this looks like it's probably a galaxy. Right in there. This is kind of funny shaped and looking very galaxy-ish. This looks like a galaxy down here. There's a fuzzy blob over here, but it's too small to really be able to tell much. This looks like maybe a galaxy. There's quite a few things in here. Yeah, I agree, Al. I really like SharpCap. It's a fabulous thing, and even the beta is pretty darn solid. I found very few hiccups with it, and so well, as usual, Robin's doing a great job, which he always does anyway. But yeah, the sequencer, I'm really liking using the sequencer. It means I just don't have to click so many buttons every night when I'm doing the same thing over and over and over again. And it's a lot of fun. And I like coding anyway. But full width half maximum is distance between 2 points on a curve where function reaches half of its minimum value. Okay, that actually kind of makes sense to me. Yeah, and yeah, John, and that's certainly not everything either. There's a lot of stuff, and you can go to the site, the SharpCap site, and download the manual and take a look through it. So it's a very, I think the manual itself is like 240 or 50 pages or something. It's quite a piece of software. Well, we'll let it finish here with this particular sub, and then I think we'll move on. Move on. But yeah, I think you can see there is structure that's starting to show up in this disk. Almost some swirls in this disk that's showing up. And what is the distance for this? Is there a distance on this one? NGC 488. Let's see if Wikipedia has it. NGC 488. Is a face-on spiral galaxy in Pisces at a distance of about 90 million light years. So this one is definitely not in the local group. It's one of the further away ones. Well, there are galaxies that are billions of light years away, so within our local area, it's not one of our local group. Its diameter is estimated to be approximately 171. I think that's supposed to be, it says 171.000. I think that's supposed to be a comma. It's supposed to be 171,000 light years, which would make sense. The galaxy has a large central bulge and is considered a prototype galaxy with multiple spiral arms. Its arms are tightly wound. Star-forming activity has been traced within the arms. The nucleus has been found to be chemically decoupled being twice as metal-rich as the center bulge of the galaxy. The nucleus is twice as rich, metal-rich, as the central bulge. NGC 488, with the exception of its smaller companions that form the 488 group, is an isolated galaxy. So this is a group. So all the other ones that we're seeing here are part of its group. Yeah, John, I'm not really much for beta software either. I just like stuff that works. I don't like problems. So, which is why it's been frustrating that my CPWI has been bailing on me or my Wi-Fi connection, and my mount connection has been dropping. Tonight it's been pretty darn good. Seems like every other night it's good and every other night it's bad. So, I don't know, but yeah, I don't usually have a lot of patience for beta software, but Robin's stuff is so good that it's a pretty safe bet with him. Well, let's see. That's not a very bright one. It's not a very bright one. Phantom Galaxy. Yeah, we could do that one. Keep working our way up here. And John, I think you requested Running Man, so we could do that. But Phantom Galaxy, let's take another shot at Phantom. Or take a shot at Phantom here, because I think we've gotten about all we're going to get out of this guy, out of the Whirligig Galaxy. Yeah, we'll finish that one more stack. Oh, what happened? Looks like we lost another. Yep. Oh, we've got our FWHM went bad. We may have gotten a little wisp of cloud come over. In any event, we're moving on anyhow. So let's go to our next target and go to the Phantom Galaxy. It looks like kind of a normal spirally kind of guy. Alright. And zoom back out here so we can see everything. Oh yeah, dead center, right there. Okay, well let's just start. It's right there. And you can see at the bottom there, when I flash that up, the bottom is much brighter than the rest of the sensor. That's amp glow. That's amp glow from the sensor. That's me really stretching the contrast to ridiculous levels on the sensor, which makes it easier to find objects, but of course adds a lot of noise. Yeah, well, I've done Running Man a couple of times now with the 533, and it comes out pretty nicely with the 533. I've never actually tried to do it with the mono, so we'll have to see what we can see. I never have. In fact, I don't think I ever have tried with the mono camera. So, Andre requests if I can do the Fireworks Galaxy. Well, that's a good question. Oh yeah, look at that. That's coming out nice. So this is a script I'm running. Yeah, so this is what that's when I go up to the sequencer here, as opposed to scripts. And now in SharpCap, you have to be careful of the terms you use, because you actually can create scripts. This is actually the sequencer. It's the sequencer that's new. And so with scripting, I believe what this is Python-style scripts that you can actually create and run from SharpCap. The sequencer kind of takes that to a much higher level of coding, where, like I said, you're basically taking blocks of, a function, dumping it over here wherever you want it in the order of your script, and then typing in whatever parameters you want, times, colors, settings, whatever. And so yeah, so every time I come up here, I basically have two scripts. My next target script, which basically saves my, it could save my image if I was doing that, and then it goes to it's the same things that I find myself doing every night when I'm going from object to object to object. It's just a repetitive thing, and so this is my run. But when I go to my start, my next target, it's this. So it basically stops the live stack, sets the exposure to 1, and then maximizes the gain, which makes it easier for me to find the next object. And then the other script I use is when I actually get to the new target and then I want to actually start imaging. I reload the camera profile for my camera, which sets all of the exposure, the gain, all the settings back to where I want it, resets the histogram that I've stretched the heck out of in order to see stuff, sets the exposure to where I want it to be for my imaging, starts the live stacking, and then deletes the old image that was in the live stack from before. And so those same things I was doing over and over and over again every night. Every night, every time you switch to a new object, you're doing the same things over and over again. And so it just gets repetitive and redundant. And so the sequencer is a way to just take some of those repetitive tasks, and with one click you're doing all that stuff. Okay, so while we keep going on the Phantom Galaxy, Andre had asked about the fireworks. Where is the fireworks? Fireworks Galaxy. Let's see where it is. Yeah, so, oh, unfortunately, no. That is now too low. That's in my western sky. I can't really go much below 30 degrees in my western sky because I've got roofline here. So unfortunately, the fireworks galaxy is not possible to do for me, Andre. So sorry about that, but not going to be able to do that one. Hey, Joy. Good to see you. I hope you're having fun in Costa Rica. I see you got a new picture on your profile there with a hat. Good to hear from you. Yeah, Joy used to be my my lot mate here, and so she would walk by my screen every now and again and see what I was imaging. That was before I started doing my live streaming earlier this year, when I would just do my own imaging out here. And so then she went and moved to Costa Rica, and so now, like everybody else, the only way she can see this stuff is on a live stream. So good to see you, Joy. Nice to hear from you. I should give you a call one of these days. We haven't talked in a bit. But this one's coming out nice, the Phantom. Phantom Galaxy. Yes, yes, and the Kona Skies miss you too, along with other people around here. There's some nice structure in this. You got some nice. It's a fairly tight spiral, where you got some nice, bright lanes here and dark lanes in between them. Got some nice detail showing up there. Let's stretch it a little bit more. I think you guys need to see a little bit more out of that. I'm also seeing what's being consistent in almost all of my images is that the upper right portion of the image has a lot brighter than the lower left. And so we've been staying in one particular part of the sky, and it looks like my mount possibly has dropped. It did. No. Let's see what happens here. Oh, it may have retook. That's the intermittent problem that I've been having with my mount disconnecting and CPWI losing connection with my mount. And this time it looks like it stuck. So usually I can just say yes to that a few times and it will behave and reconnect. But now and again it will just not reconnect. And the only solution to the problem, and we've tried a number of different things, even telnetting into it and trying to reboot it and blah blah blah. The only thing that seems to be able to correct it is power cycling the mount and realigning, which is just Celestron's crappy Wi-Fi implementation where their Wi-Fi devices do not handle it well when the device on the other end drops for some reason. Power fluctuation or whatever. When the thing on the other end drops temporarily for some reason, the Celestron devices, whether it's the built-in Wi-Fi like on my Evolution mount or one of the Sky Portal dongles, they do not handle that situation well, and they sometimes just won't reconnect until they're power cycled, which is kind of crappy. John asked if I have other imaging telescopes. No, this is actually my only imaging telescope. In fact, well, no, it's not, I can't say it's my only telescope. The only other telescope I have is a little Astronomers Without Borders 130, which was my last imaging scope before I got this one. And so those are the only two scopes I have. And imaging is all I ever do anymore, so I don't really need to have a scope that isn't optimized for imaging. So I just use this one scope, and I just love it. And in fact, the only way I would upgrade this scope is if I were to go to another imaging scope. You know, I kind of lust after a RASA, but they're tons of money, and honestly, I don't think going to a RASA and a 183 would give me a whole lot more quality images than I get with this in the 533 already. So I'm pretty darn happy with this scope. So I just switch cameras. I just use the 178 and the 533 on this, both of which I purchased because based on the focal length of this, they both provide a decent field of view for what I want to use them for, and good image scale as well, which is the resolution and detail in the images. And because as you go with longer and longer focal lengths, you want to go with bigger and bigger pixels on your camera to accommodate. Otherwise, you are getting way oversampled and basically throwing away, you know, aperture, because you're just taking in way more than the camera can use. So you want to keep going up in pixel size as you go up in focal length. And so for my little 600mm focal length here, I need some of the smaller pixel cameras. So that's why I use the 178 for my mono and the 533 for my color, which provide me a nice balance of field of view and an image scale for the stuff I like to shoot. So hey Kirsten and John, thanks. Yeah, this is the Phantom galaxy. So this is a fun one, and we're about to actually go to a much bigger one. I'm going to go do Triangulum, and then which is the second closest galaxy to the Milky Way, or at least the second one that we typically see. Actually, the Dwarf galaxy that we were just looking at is supposedly even closer, but hardly anybody ever looks at that because it was such a faint little guy. So we're going to go do Triangulum next, which is always a spectacular one. The biggest problem with it for this camera is that it's probably going to be a bit bigger than my sensor, so it may not all fit in my sensor, but we'll just see what we can see. But yeah, this is the Phantom Galaxy, and I think that came out pretty darn nice. Nice structure in that galaxy. And did I distance? So this one, okay, so this one is only 30 million light years away. So this is one of our more local guys at only 30 million. I think anything from about 15 or 20 or 30 is more of our local group of folks. And as opposed to the ones that are 80 and 100 and more that are more distant. Let's see if it is part of M74. Oh, and this is actually M74. M74. Let's look up M74. Messier 74. Yeah, M74 is apparently a military vehicle. Messier 74 is a spiral galaxy in Pisces at a distance of about 32 million light years. The galaxy contains two clearly defined spiral arms and is therefore used as an archetypal example of a grand design spiral galaxy. The galaxy's low surface brightness makes it the most difficult Messier object for amateur astronomers to observe. However, the relatively large angular size and the galaxy's face-on orientation make it an ideal object for professional astronomers who want to study spiral arm structure and spiral density waves. It's estimated that M74 is home to about 100 billion stars. And somehow I got... There we go. All right. Let's go take a look at M33, our Triangulum, and then we will, which is this bright fuzzy spot here, and then we will go try Running Man. Yeah, see, it's gonna be bigger than my sensor, so we'll give it a shot. But hey, what the heck? All right. Let's close this up. Next target, 78. I kind of did this in backwards order. All right. Actually, I'm surprised I can't see that without stretching it, but there it is. Right there, pretty much dead center. All right. I don't think 60 seconds will be too long for this. Too bright for it, so... we will see what we can see of the Triangulum. This one is, like I said, our second... Well, the second closest galaxy to us that really we observe a whole lot, but that Dwarf galaxy that we just were looking at was actually a bit closer than this. So, but it's so hard to see that nobody really ever looks at it very much. But this one is a big, spectacular one, unlike that Dwarf galaxy, which is really small and therefore hard to see even though it's close. This one is a much bigger and more spectacular one, and there's why. there's why we like to look at it. Too bad my camera isn't sideways in here. I'd be able to see more of it. We're 90 degrees out of orientation to see the whole thing, but well, actually I can come out a little bit here. Well, not really. That's about all we're going to get for it, but yeah, that is a spectacular guy there. In fact, I'm going to have to, it's so bright, I'm going to have to back off on my black level. Back it out here, and then back this out here, so we're not quite so blown out, but still get some decent image in there. But yeah, this galaxy actually is perfect for my 533. It fits in the 1 degree. My 533 has a field of view of just a titch over 1 degree, and this fits in it very nicely. And even though and it has a little bit of color, but not much. The reason I like using monochrome cameras on galaxies is because, first of all, monochrome cameras are more sensitive than a color camera is. Because a color camera is basically a monochrome camera with a RGB filter thrown over the top of it, which just filters out a lot of the light coming through. But it's what gives us the nice color images. So the monochrome camera that doesn't have that is more sensitive. So they're better at doing fainter stuff like galaxies. Furthermore, galaxies, because they are so far away as compared to nebulae and star clusters and things that are within our own galaxy, other galaxies are so much further away that they don't really transmit a whole lot of light anyway. Yes, the Hubble imagery and astrophotography images of a lot of galaxies do have color in them. But that is because they have spent hours and hours and hours just with their telescopes on that one object, just tracking that one object to collect light, to collect photons. And it takes that, I mean, you have to collect and collect and collect data for a really long time in order to be able to eke any sort of color out of them. So, because the light is just traveling so far. So, so that's why monochrome cameras, I think I like shooting my galaxies in mono. Did I not see that calculated transform, detected 17, 18, Okay, well, everything looks like it's okay. What did we do? Detected 18, calculated 3, 1, 2, 3, 1, 2, 3. I'm only seeing 3 in there. Didn't look like it actually added that last frame, but I might have just been seeing things. Because it looks like it hasn't rejected any. So, no, seems to be doing fine. Okay. Somebody has marketing down on Wikipedia. Oh, you like the Grand Design Spiral Galaxy, huh? Well, believe it or not, I think that's actually boring old astronomers who came up with that one. Because pretty much on Wikipedia, it's, I think pretty much it's us that populate that with information. I don't think Wikipedia puts that stuff there, or they aren't responsible for it or whatever. But yeah, so I don't know. But yeah, you can see all kinds of little puffs of light in here. Lots of different, bright spots that are probably star-forming regions. And again, as with all the time when we're looking at galaxies, any of the stars that you see in here are in our galaxy. Those are all way in the foreground that are in our galaxy. So any stars you see in the night sky are always in our galaxy, because other galaxies are so far away that you can't see individual stars even with the most powerful of telescopes. You can't see individual stars in galaxies that are millions, if not tens, if not hundreds of millions of light years away. So you have to kind of pick out the portions of the galaxy from the foreground stars and see what are the pockets of brightness that actually are part of the galaxy itself versus a star that's in our own galaxy that's gotten in the way. But Triangulum is a pretty spectacular target. Oh, I missed a question from you up there, John. How are you using a serial to USB adapter with FTDI chip, or is this strictly Wi-Fi? Right now, it's strictly Wi-Fi. I was using a serial cable, actually a USB cable, into the bottom of my hand controller to control the scope, and I did that happily for months, and then I started having weird wonky problems. And I'm pretty sure it's just that the USB port in the bottom of my hand controller started going wonky. And so I started having weird problems. And so that's when I started to use CPWI and just connecting wirelessly to the Evolution, which has, it has Wi-Fi built right into it. So why not use the Wi-Fi that's already built into the mount and just discard the, not use the hand controller at all. And so now the hand controller, which is actually the StarSense hand controller that I'm using, but the hand controller now just stays in the box. I don't even use it at all, and I connect wirelessly with via CPWI to the mount to control the mount. And in theory that should work really cool, but like I said, CPWI does have these intermittent drops, and seems to be behaving really well tonight, so that's a good thing. Last night I came out here and it was dropping me all over the place, so it seems to be completely random as to what it's doing. So, but I have used, I actually have a Celestron cable with an FTDI chip in it for when I used an older hand controller, just a regular Nexstar Plus hand controller that came with the mount, which just had the RS-232, the RJ connector in the bottom of it, not the newer USB. So I was using that before, but then when I got the StarSense came with the newer hand controller, so I was able to just go directly USB right in. So I could, I basically my FTDI chipped cable is just sitting in the box unused now, and it doesn't actually get used. I really am liking CPWI too. CPWI is just it completely replaces your controller, and it makes a lot of things a lot easier. Number one, you don't need GPS because you don't ever need to add the date and time and location into your hand controller to start an alignment, because CPWI, because it's on the computer, automatically knows what all that stuff is. So you never have to enter any of that data. It has a much more powerful what am I trying to think of? not alignment system, not modeling. It has a much more accurate model than comes with the hand controllers, and so you get actually much more accurate when you do an alignment using CPWI as opposed to the hand controller. You actually get a much more accurate alignment and much more accurate sky model. And it allows you to take a lot of extra points to even increase that accuracy more. So I really love using CPWI. I actually like using it a lot more than the simplistic hand controller, and especially since I already am using laptops and they're already out here anyway, it's a no-brainer. But this disconnect issue is just a pain. And but I believe I have a solution on the way. So we'll see. You know, if you're a member of the Cloudy Nights forum, you know that we've been working on. He's basically a retired embedded systems engineer who does a lot of Arduino work, and he's created brand new dongles for these for Celestron mounts that have GPS, Wi-Fi, Bluetooth, and a USB PC port built right in, and it's far better than what comes with the mounts themselves from Celestron. And right now what he's working on is an Ethernet dongle. So you can plug an Ethernet dongle directly into the mount and plug a Cat 5 or 6 cable from your laptop directly into that dongle and connect via Ethernet directly to the mount, which will avoid all Wi-Fi problems and all USB weirdness that can also happen, because Ethernet is much more robust, reliable, and than Wi-Fi is. So certainly Wi-Fi is, but even USB, which can be a lot of proprietary drivers and stuff. So hopefully that is going to solve all these disconnect issues. But yeah, I really like my Evolution, and I love CPWI, and I just hope we can get rid of the disconnect things. Curtis, the CPWI is available right on the Celestron website. You just do a search for Celestron CPWI. It's right. It's free. It's a free download right off the Celestron website. And which mounts does it work with? I believe it works with every computerized Celestron mount. But it'll tell you on the CPWI page. It'll tell you right on their page what it's compatible with. But I think at this point, because it's been in development for a while now, I think by this point it's actually now compatible with just about every computerized mount they've put out within about the last 10 years or so. I don't think it goes all the way back to some of the old GPS models or the old original Nexstar I models and things like that. But anything that they put out, I think within the last decade or so, it certainly does work with it. I know it worked great with my my SLT, which is something that's been out for quite a while. So, yeah, I really like it much better than the hand controller. And once the disconnect issue is resolved, that's going to be very cool. Okay, so there is the wonderful Triangulum galaxy. What about that piece of hardware you mentioned? Oh, you mean the dongle that's being created? Yeah, go into the Celestron subforum, Curtis, on Cloudy Nights, the Celestron specific mounts forum, and you'll see there's 3 separate threads that he's got going with regard to his DIY, or what he calls homebrew. He doesn't use DIY. He's Canadian, so he doesn't. He uses funny words sometimes. You know, as Canadians are. But sorry, just joking. He calls them homebrew. So he's got homebrew Wi-Fi and GP. His original thread was homebrew GPS. He just created a GPS dongle that could be plugged into any Celestron mount, so you could have GPS no matter what, and didn't have to buy the overpriced flaky Celestron one. And then that turned into him creating a new Wi-Fi dongle to replace the problematic Sky Portal. And then that turned in, then he expanded that into from just Wi-Fi to also include Bluetooth, and then he incorporated the GPS from the other project into it, and he put a PC port on it, so it just kept kind of growing. And then he actually saw me struggling with the Wi-Fi on my Evolution, me reporting about it because of my live streams, and that gave him the idea to start this Ethernet project. So he's now working on creating, and he's got it working already, he's now working on creating a Wi-Fi dongle that will plug directly into a Celestron mount. So we'll see what comes of that. All right. Now John mentioned Running Man. Let's go over here and go over to our Orion here, and let me just make it target it. Running. Whoa. Hello. Running Man Nebula. Okay, right there. All right, let's send you over there, which is going to be on the other side of the sky, which is actually good. I want to go try another part of the sky to see if I still have the light issue in the upper right versus the lower left. If it's because I'm picking up stray light from somewhere, or if it's actually just amp glow from the sensor, which is probably most likely. All right. Yeah, there we go. So we've got those guys there. Yeah, see, these three look like these three here look like these three. So I think we are going to have to, and these two here look like these two, I think. So I think we're going to have to move it a little bit. Well, yeah, I'm just going to move this whole cluster in there, because I think that whole thing is going to be good to look at. Oh, and here's another thing I really like about the new 3.3 beta is the scope movement controls are now hotkeyed. So I don't have to go over and fish over there with the mouse to you know, I don't have to come over here and click on the arrow keys, which when you got a really cold mouse and really cold hands sometimes doesn't work so good. Now it's hotkeyed directly. Control IJK now directly control the mount, which I think is just very cool. All right, this is still moving a little bit, so we'll give it a few seconds here to settle in. And let's. Oh, you're still moving. Come on, you. Settle down. I can still see it moving and moving. It's still. Alright, we'll start. Hopefully the first sub won't be mushy. But John, are you sure about CPWI not working with mounts that are pre-Nexstar Plus? Because I'm pretty sure my SLT, it worked with my SLT, which had just a regular Nexstar. It wasn't the next. Yeah, it was the original Nexstar hand controller. So I thought it did work with the older one. Anyway, it says it right on the page. Just look up the mount. You know, because there is right on the CPWI page on the Celestron website. It says which of the Celestron mounts it works with, and it's a pretty big list. Well, there's the Running Man. All right, let's see if we can. Like I said, a little more contrasty, but that's looking pretty good so far. Yeah, boy. It's just even the difference right now between this and my 533. My 533 The first sub never looked this bright. Even with my super sensitive new 533, it never looked this bright. So, mono cameras are just incredibly sensitive. They're just really super duper sensitive cameras. And this is all a nice spectacular blue. If you go look at my live stream from, I believe it was a week ago, the one where I did the January Observing Challenge. I'm pretty sure that was a week ago, Monday night a week ago. And this Running Man was one of the objects I did. So if you want to see it in color, you can go. I did all of the objects around Orion because Gary, when he made the list, he basically stayed focused on Orion, which in the wintertime is our big, bright, beautiful constellation. The easiest one to see in the winter sky, pretty much, other than the Big Dipper maybe. But it's a really good one for us. So in the wintertime, so he made most of his January challenge objects around there. So I used the 533 on that and saw all this stuff a week ago with the color camera. But I have never shot this with the mono before, so this is interesting. Oh, and it has ignored a frame. What happened here? Yep, FWHM went up. I got a blurry sub, so it rejected it, just like it's supposed to do. That is the FWHM filter's job. If it gets a streaky, blurred frame because a cloud rolled over or the mount jiggled or something, a puff of wind comes up, and actually you might even be able to hear the tin doors of the shed next to me rattling a little bit. We do have a little bit of a puffy breeze that's just picked up, which may send some of my exposures to the waste bin if the scope jiggles a little too much in the breeze. But it'll probably be it's done pretty well with in breezes. But I may even at some point rebuild my wedge, because this wooden wedge that I made was actually for my ETX70. It was designed for a much smaller, much lighter scope. But I made it out of 3/4 inch plywood, cabinet grade plywood, because my dad always taught me to overbuild things. So that's what I did. And so when I put the Evo and the imaging newt on it, I thought, nah, this is just a proof of concept to see how well the wedge works. Ow! Gotta stop yanking that cable. To see how well the wedge works, because I'm not sure that this wedge is probably going to be too small. So we're just going to see how well the scope and the mount perform at that angle to see if this will even work. And so I put it on there, and it ended up working so well that I've just left it. I guess at that point I overbuilt for a reason. But if there is a breeze, a little bit of a breeze, I will, especially when I'm doing 60-second subs, it'll definitely get noticed and the frame will get rejected. So I think the only way I could really improve on that is to just break down and make a bigger wedge with bigger pieces. Maybe go to 1-inch plywood, and to just give it a little bit more rigidity, so that right now in light breezes I'm still mostly okay, but if I go to a little bit stouter materials, it would be even better yet. But you can kind of see the Running Man there on his side. Kind of a guy running. Just love the 178 mono. It's just a great camera. Just super sensitive and really does a great job. And now I'm not really seeing it being tremendously light up in the upper right versus the lower left. So maybe I was just pointed at that western part of the sky. I was just picking up some stray light. But this is like all of the nebulae all over the Orion complex. This is a rich star formation area. And, well, one of the interesting things that we learned the other night when I was reading up on this in Wikipedia is that originally the thought was that these stars were formed in this gas cloud that they are now illuminating, and that they're beginning to spread out into the sky, spread out into space, just like they're doing in the Orion Nebula itself, which is a rich star-forming area. And what we read actually in Wikipedia is that now they think this is not the case. They think these stars, this cluster of young white hot stars that's beginning to spread out, is just moving through an area of dusty cloud that's in the Orion molecular complex or whatever it's called, and they're just illuminating random dust cloud that they happen to be traveling through at this period in time. And so now the theory is that the dust and gases that they're illuminating here in this beautiful nebula aren't actually what they were formed from, but that they're just cruising through it. So John asks, doesn't Celestron offer an HD wedge for the Wi-Fi model? Yeah, Celestron offers actually Celestron offers a couple of different levels of wedges. Yeah, and I think they do call one of them an HD, and I think that's just which in this case is not high def but heavy duty. There are two, I believe, wedges that they offer. The first one is the regular wedge, and that is for the SE series and the Evolution. And so either one of those, the SE6, SE8, and the Evolution 8 and 925, can all go on that wedge. And then they make the HD level wedge for the much bigger and heavier CPC scopes. And maybe even the EVO 925 is for that one too, because the EVO 925 is a pretty heavy scope. And so those are, I believe, the two levels of wedge that they currently make right now. So, but again, you should be able to just go type wedge on the search box on their website and find that out. But I think those are the only two wedges that they're offering right now. Yeah, and now we're starting to reject subs. May have a little bit of cloud going over, because normally the numbers have been pretty nice. But now all of a sudden we just jumped up and have gotten some, you can see we've got a little bit of mount movement or a little bit of breeze or something has just blurred the stars a little bit. So we just dropped a couple of subs. But anyway, this is such a nice, bright, spectacular object that even what we've got right now is pretty darn nice. I don't think we need to push it. Thanks, Al. Glad you stopped by. Good to see you again. But this is, already pretty good. So. I've been going for a little over 2 hours now, so I actually think I might call it a night unless somebody else has something something else that they want to see. Oh, turn on the constellation art. How the heck it's not C? Oh, it's the constellation lines. Maybe it's A. Nope. Forget how to turn off the constellation. Oh, I accidentally hit buttons, and constellation art is R. I accidentally hit buttons, and it will turn features on and off, and because I'm trying to type. This was when I was trying to type into the search box, and I didn't notice that the cursor was in there, so I'm typing keys, and meanwhile Stellarium is interpreting that as hotkeys for all kinds of stuff. So anyway, yeah, so I think I'll probably just end up calling it a night here. Active galaxy. You know, I did actually have, yeah, there were a couple of things in here that I did want to look at. 1622 is one of them. Actually, Gary, we talked about this the other night. And so I think I'm going to try 1622, which is going to be another faint galaxy, but this is actually a group of 3 galaxies that it exists right over this star in Eridanus. And so we're going to try that next, and that will be the last thing. But unlike this big, bright, beautiful thing, this will be a much smaller thing, but it's going to be a group of galaxies, 3 of which we can see pretty well. So that's what we're going to do now. Next target 178. Am I part of LVAS? John asks. Yes. Yes, I am a member of LVAS. And in fact, I help them with their live streams. We've got one coming up on this Saturday night, I believe. We're going to be doing our regular monthly live stream. And yes, I am a member of theirs, and we do our live streams together. Where are we? There you are. All right, now we should see one nice bright star in there, and there it is. And then these dim and bright there are dim and bright there. So these are going to be, yeah, right up in here. So I think I'm going to bring this down a little bit and over a little bit. Oh, Julian. I'm assuming you mean Julian Schul. Yes. Yep, know him well. Yeah, he's often on our live streams as well, our monthly live streams as well, doing showing what's on his big 16-inch scope, and so yeah, Julian's a cool dude. I like him. He's funny. He is quite a character. Whether you're at an actual star party with him or just doing a Zoom thing, he's a fun guy. All right, so I think we're probably about centered where we want to be there. So let's start the imaging and see if we can see how many. This will be another how many galaxies can you count kind of experience. So we'll see how many we come up with here. Oh, thanks, Kona. Glad to see you here, and look forward to seeing you again. Glad you enjoyed yourself. Old friend from Connecticut, the Phoenix. Hey, you bet, DJ. Good to see you again. Yeah, anytime, you know, if you miss any part of these, you know, I mean, you just come back and click the link tomorrow or next week or next month, and it just, these live streams turn into regular videos. My parents are on the East Coast, and so, you know, they're in bed before I even start these. So, you know, they usually get up the next morning and watch them over coffee or something. Ooh, well, okay, there's our first one, but the mount was obviously moving, so but you can already see at least 3 of the galaxies in there. But we're going to have to start that one over again because the mount hadn't quite settled. Oh, the Phoenix is what he calls the 16. Oh, okay, cool. I didn't know that I actually knew that. I've looked through it a number of times, but I don't know that I actually knew he called it the Phoenix. So I'll have to bring that up next time. Next time he's on the live stream. Which, like I said, I think we're having the. I think we're doing this Saturday. Is the 16th. Yeah, so I think this Saturday we're doing a live stream, and he usually attends that if he can get the scope set up and the weather's appropriate and whatnot. He usually attends and sometimes shows what he can see through that 16-inch scope with a camera, which is just spectacular. Well, even this one's a bit blurry. The scope isn't. It's like the scope isn't tracking exactly right, but we'll go with it because it's probably good enough. But yeah, it looks like you can see how the stars are all ovaled side to side, and that's just because we're getting either some breeze or mount movement or something that the mount isn't tracking exactly right. Follow the sharp. Mooch, I know what you're trying to say. I bet you this is Sherpa and you keep getting auto-corrupted. I have a feeling that's what's going on. Alright, let me get this histogram fixed because we've gone to a much dimmer object. So let's get that histogram fixed over there a little bit. Well, if you're in Connecticut, there's well, I don't know, Astronomy Club meeting. Yeah, you'll probably be done before we get started here. I think it starts at 6 our time, so that would be, what, 9 your time? Ha! And there, yes, Lola. I have a feeling Lola means something else too. Maybe we'll just drop the last letter there. You've got to love autocorrupt. It has mangled more messages than anything else in existence. So, back to our original thing here. How many galaxies can you count in this image? I know even below this star in Eridanus, there are more, but in fact we can just kind of almost expand that right out and get it almost right out of the picture. But there are definitely quite a few galaxies in here that you can see. Yeah, John, we should be going. You know, it starts at 6. We usually go at least a couple of hours, so we'll probably be going till at least 11 your time. So even if you don't show up right off at 6 o'clock our time, you know, even if you don't get here till 7, that's fine. We'll still probably be going for a little bit. But this is the Eridanus A. No, this is NGC 1622. We didn't get to the Eridanus A group because it's already gone too low. We were looking at other things, and I had actually created a little bit of an observing list for tonight, but we were looking at other things, and so we never really got there. But this was one that I'm doing this for you, Gary. Looks like you're not on live, but you'll probably watch this tomorrow. In my last live stream, this was one of the things that he requested, and we looked at through the 533, the color camera, and so I said I would try this on my next Galaxy night, and it's a pretty cool thing. So obviously we've got these 3 here that are the biggest and brightest ones, but even this smudge here is also a galaxy. And then over here we can see, oh, look at, we have a satellite photobombing our image. Satellite streaking right through, photobombing our image. Anywho, here is another one here. This is obviously a spiral that we are looking at almost edge on. A nice dim little guy there. There's also, right up here in the very corner, you can see that there's another nice little fuzzy oval up here. That's a galaxy. I don't think there was anything. Well, I know there's more well below this star that we could see with the larger sensor of the 533. But tonight with the smaller sensor monochrome camera, this is we still got what, 7 or 8 in there. So, but this is a nice little cluster of galaxies in here. Well, I'm glad you joined me here, Mr. Muccio. Good to see you. Hopefully, you'll be able to get out and come on a hike with us again sometime. It'll be fun to hike with you again. Oh, there we go. The satellite finished photobombing our image. Finished streaking across. Let's see. I think I could also stand to push this stretch a little bit. Brighten it up a little bit more for you guys. I got to keep remembering that in order for, because the video compression algorithms cause so much signal loss, I've got to remember to keep my stretch pushed, and I actually have to make it look pretty grainy, blown out, and crappy on my screen to make it look good on the live stream, because the live stream is so lossy. But even to the point of making it a little noisy. Yeah, I heard that you fell. Well, I hope you're up and about and doing better. Sorry to hear about that. But I've got to. That's actually why I'm you know, the brightness issue is why I have to keep a second computer running next to my primary computer that's controlling the scope and running the software and all this stuff. I have to actually keep a second computer next to it just to monitor the live stream. It just stays on the live stream and does my Wikipedia stuff, because I have to constantly monitor the live stream itself to know how much I have to make it, how much I have to brighten it for you guys to know where it's at. Because if I make it look good on my screen, it's way too dark on yours. So I have to make it look really crappy on mine to make it look good on yours. So sometimes I'm actually having to just make my adjustments based on what I'm seeing on the live stream, which is a little bit weird because the live stream is typically about 15 or 20 seconds delayed from what I do here. So I sometimes have to do an adjustment and wait a bit and do an adjustment and wait a bit. So well, thanks, Mooch. I appreciate it. Yeah, I'm finding it just really fun. I've been doing this imaging for a while now. For a couple of years, I've been doing imaging with various scopes and various cameras, and have eventually improved my setup until I am where I am today. But been doing this for a couple of years, and I really enjoy doing it. Like I was saying earlier, when I started using a camera, I was finally able to see things the way I've always wanted to see them. And not just these faint, fuzzy little gray things that you can barely make out in an eyepiece, but I can actually see stuff, you know? I mean, even these really small, really faint objects with a camera can be really made to pop, and I can really see the things that I want to see. And so I've been doing this for a while and really enjoying it. And then the pandemic starts, and one of the things that I was enjoying was going and doing star parties and bringing my laptop and, set the camera up and show people at the star parties what was on my, what my scope was looking at, what the camera was seeing, just do it live. And that was a lot of fun. And then the pandemic showed up, and one of the many, many casualties of COVID, and there's another satellite photo bombing the bottom left-hand corner. One of the many, many casualties of the pandemic is that obviously you can't have star parties anymore. So then I started seeing, there's people doing this, live streaming this stuff. So I've now started doing my own live streams, just of my own sessions here in my backyard. Not very many people have the kind of dark skies we have here in their backyards, so they get to see what it's like doing astronomy from here. And not everybody has our southwest desert weather either, and a lot of people spend the winter under clouds and have a lot more humidity and moisture and light pollution and all kinds of things. So I started live streaming this, and it's a hoot. It's a very complex task, and there's a lot of moving parts, and it's a combination of a lot of disciplines, of not only astronomy but the electronics gear side of astronomy, plus computers, plus networking, plus dealing with broadcasting software and understanding compression algorithms. And it's a lot of disciplines that have to come together to be able to live stream this stuff. And so not very many people have those combination of things, or the desire to combine them in the first place. So but I'm just finding it to be a hoot, so I like it a lot. Yeah, Kona, John fell and broke his kneecap a few weeks ago. That's just lousy. And we miss you on the hikes, John, so get well and hike with us again. Yeah, we'll give this a couple of more minutes. These are faint objects, so you can collect a little more light on them. But in fact, I can probably even push that stretch a little bit more if I wanted to. Well, let's just see if we do this. That will probably make a big enough difference right there. We'll see how that comes out. I'll wait my 20 seconds here and see how it comes out on the stream, if that's too much. Aw, John, you're gonna make me blush. It's a good thing I don't have a camera on me. But we do have some pretty nice skies here. We definitely do have our challenges living here in the middle of the desert, don't we, John? But there are definitely some upsides too. And one of the nicest things I find about living here is that's my astronomy. You just can't do this kind of stuff in your own backyard in very many places in the world right now. So this is pretty spectacular. Yeah, I think it's worth it too. Astronomy, the hikes, the beautiful open spaces. It's all good. Yeah, but I think we got what, at least 6 or 7 galaxies in that image. So that's pretty good. So Gary, hopefully you'll watch this tomorrow or whatever and see that I did actually shoot these galaxies for you in mono. There's a pretty nice little group. But at this point I've been going for about 2.5 hours, so I think it's about time for me to say a good night and sign off. And go inside and get me a little something to nibble on and warm up again. But thanks everybody for being here tonight. Really appreciate you all being here with your chat and your questions. It is a little surreal just sitting here talking out loud to myself all night, but so it really helps when you guys chat and say hi and give me something at least to respond to. Let me know that you're out there. But thanks for coming, and I will see you guys next time. I'm not sure when my next night will be yet. It's really totally weather dependent. As long as the moon is dark, it depends on the weather. Once we get into the moon time again, then I'll disappear for a couple of weeks, but should be another one coming up here probably in the next few days. But in the meantime, thanks everybody for coming, and good night.